So today we're talking about the third angle's theorem. The third angle's theorem tells us that if two angles of one triangle are congruent to two angles of a second triangle, then the third angles of the triangle are congruent. So if two angles of one triangle are congruent to two angles of a second triangle, then the third angles of the triangles are also congruent. So in this example right here, we can see that angle C is congruent to angle K. Angle B is congruent to angle J. Since we know that these two angles and these two angles are congruent, we can also assume that angle A is congruent to angle L. So now we're going to practice this theorem, writing some proofs. So the first thing is we're going to set up our statements and our reasons. So first we're given this list of statements. So we're given that angle L is congruent to angle P. We're given that side LM is congruent to side PO. We're given that side LN is congruent to side PN. And we're also given that side MN is congruent to side O, and this right here is supposed to say N, not P. So that's what we're given. So we have all these statements, and we're just going to list given as our reason. Next, we have the statement that angle LMN is congruent to angle PNO. So it's trying to tell us that this angle is congruent to this angle. Well, we can see here that we have two lines intersecting each other to make an X. When we have two lines that intersect in an X, the angles on opposite sides of each other are vertical angles. So we can say that these two angles are congruent using the vertical angles theorem. Next, we have angle M is congruent to angle O. So we have M down here and O down here. Well, we already know that L and P are congruent, and we know that this right here is congruent because they're a set of vertical angles. So this is where we would use our third angles theorem. We already have two angles in the triangles that are congruent, so we can automatically say that the third angle is also congruent. Well, up here it wanted us to prove that triangle LMN is congruent to triangle PON. So now we can say that because we have all of our sides congruent and all of our angles congruent. So we can say that corresponding parts of congruent triangles are congruent. So since all of our corresponding parts are congruent, we know that our two triangles have to be congruent. So let's do another proof. First, let's start off with what we're given. So we're given that side QN is congruent to side OP. We're given that side QP is congruent to side ON. Well, we can also look right here and see that the two triangles are sharing this side. So we can say that side NP is congruent to itself, side NP, using the reflexive property. If you remember from topic 2, reflexive property is just the same thing on both sides of the equal sign. In this case, it's side NP. So now that we have all of our sides covered, let's move on to our angles. At the beginning, we were given that angle Q is congruent to angle O, so Q is congruent to angle O, and angle NPQ, so NPQ, this angle right here, is congruent to angle PNO, so PNO, this angle right here. So we say that's given. Well, we know that two angles are congruent to each other, so we can say that this third angle, QNP and ONP, are congruent using the third angle theorem. Again, it wanted us to prove that QNP is congruent to triangle OPN? Well, we can say that because the definition of congruent polygons. We could also say the CPCTC. So this is just some reminders about what reflexive property, symmetric property, and transitive property are. These are things that we covered in topic 2, so if you want to hear about those in more detail, you can go back to the videos over topic 2.